Hello, good morning, good afternoon, or good evening, whichever part of the world you're from. Glad to be part of this really international community. I know I see people here chatting, checking weather at different parts of the world. But welcome to this edition of the workshop on Introduction to NoSQL Databases. As many of you who have been on our workshops together, the first thing we do is make a sound check. So I myself, Rags, I will introduce myself in a little bit. But Artem, can you say hello and make sure that the sound is good?
Hello everyone. Hello everyone. Glad to be here and talk about NoSQL databases to you.
Perfect. All right. So let me see if I can share my presentation and then we can go from there. Okay, so I'm good. And let me go ahead and present. Okay. So again, my name is Raghavan Srinivas, and we are here to talk about Introduction to NoSQL Databases. Welcome again.
Can you go to presentation mode?
And what we have here is the famous Artem Chibotko. Hopefully I'm saying that right. But he can geek out for hours about data modeling. But he's here today. And Artem, why don't you introduce yourself?
Yes, thank you. Rags, indeed I love data modeling and data management in general, data quality, data analytics, all those kind of things about data. I did also the Cassandra data modeling methodology. Maybe you use it, maybe you've heard about it. But I'm also a user of databases. I use dozens of different databases, and I'm using different types of databases these days, whether it's NoSQL, Relational, or modern data warehouses like Snowflake and BigQuery. So today I'll be happy to share some of my experience, some of my knowledge about those databases, about NoSQL databases specifically, and we're gonna talk about several of them. I'm also Google Cloud Certified Data Engineer, and I'm proud to work with Cassandra, AstroDB, AstroStreaming, Pulsar. We're gonna discuss those technologies as well. Rags, back to you.
Perfect. So my name is Raghavan Srinivas, and for whatever reason, people in the world have a tough time pronouncing my name. I have no idea why, but I just go by Rags. Rags on LinkedIn. I'm Rags NS on GitHub, and I'm Rags S on Twitter. I just can't make up my mind, right? But I basically I'm a mechanical engineer. Cut the mentee music. I thought I did. Let me try that. Just give me a second. And I've cut the mentee music. If it's still on, let me know. Is the music bothering? But if not, let me keep going. Let me know if it's still on. But really, welcome to everyone. And I think Artem and I were talking about this. It's so much easier when you're live and you don't have to worry about these kind of virtual tools. But I think we have created a great community, and you guys are part of the community. And really, I want to welcome you back for those of you who have been here before. But again, to go through my introduction, I'm a mechanical engineer. I've done a lot of distributed systems. Typically, mostly middleware. So as long as things are working, nobody notices me, right? And the moment things don't work, they will find me, right? I love to teach. I love to communicate. I live in Boston, where I've taught a number of undergrad and undergrad courses. Actually, Artem also has taught. So the idea of our group is to level up developer skills, no matter where you are, whether you're starting or whether you are an advanced developer, and we'll talk about all that in a second. I'm a big fan of what is referred to as the inner loop, which is really about developer productivity, where you do these things, multiple times during the day, and you want it to be as quick, as easy, as seamless as possible. And with Kubernetes, with some of the newer platforms, it's a lot easier but it's still not there yet. I mean, this is what we've been striving to do for almost 3 decades. Okay. So, although you see Artem and me on the screen, there are plenty of other people who are helping put this together. In fact, there are some people who are not even on this screen, all around the world, all trying to help, basically make sure that you guys have a good time during the workshop. You have some fun, but more importantly, you also learn, okay? So we will. This is kind of the agenda for today. We'll this is going to be about 2 hours. So we will. It'll be pretty fast. But at the same time, you will have instructions just in case you're falling behind a little bit. No worries. I have fallen behind plenty of times, and all that I do is go back to my instructions and kind of look at it, right? If you want to, you can just hit exclamation GitHub. And Nightbot will respond to you about where the instructions are, and you can start following that. Okay. We are live streaming on both YouTube and Twitch. Just in case YouTube goes down, and we've had some issues before, you can go to Twitch, but we respond only to YouTube chat. Okay. So there are 2 things to be aware of. If you want to chat, you can either go to YouTube or you can go to Discord. We recommend Discord for more, detailed discussions, something that are probably going to last beyond this workshop, right? And then, of course, there is mentee. So when we get to the mentee part of it, don't do anything in chat, do everything on mentee. And for some of you who have attended this, the drill. It's pretty straightforward. I think that's good enough for that slide, but there are plenty of resources, and I keep talking about this. This is a golden age for developers. There are so many resources, and the best part of that is it's free, right? Most of it is free, and I think you can really experience a lot of this. One of the first things, I come from the Kernighan and Ritchie side of the world. Remember the Hello World, right? So time to first Hello World is so quick these days because you can do a lot of things. You can get started pretty quickly today. Okay, so some of these are GitHub. We use what is referred to as Gitpod. Today we are not going to use Gitpod, but typically our workshops use Gitpod. And then of course there is Astra, which is what we call as the serverless database. And the nice thing about all our workshops, nothing to install. Just come, do stuff with us. Practice, and then have some fun. Okay. So I've said enough, but we're not going to let you easy, right? We will make you do some homework. So if you're serious about kind of earning a badge, if you want to earn a badge, bragging rights, as some people would say, maybe your salaries will go up depending on the badge. No guarantees there. But I think. The important part is that you learn a lot by the homework as well. So you do practice, then go back and try it out. We typically don't have a time frame for submitting the homework. We are not, a very tough grader. Typically, we recommend like 2 weeks after the workshop. There are plenty of other badges as well. I don't know if we have. Who has how many badges and leaderboard on badges and things like that. Maybe we should start something like that. But I know that many of our attendees, they like this part, and just earning the badges, a variety of different ones, like intro to NoSQL, Cassandra data modeling. Maybe Artem will be back for that. Event streaming. Building a to-do app, a very simple to-do app, Quarkus, Spring Data, you name it. Okay, so I'm not going to spend too much time on that. All right. So there, again, some of you have seen this before. What we do here is we're going to go into mentee. Okay, and to go to mentee, what I have to do is I have to do a couple of things. So you may also want to subscribe to our workshops. You subscribe to our link, and we'll put that out at the end as well. But just in case you don't stay till the very end, just wanted to inform you right now. With that said, let's go to mentee. Okay, and for those of you who have done mentee, you know the drill. But let me make sure I go back to something. All right. Okay, so let me present mentee. All right, give me a second here. All right, let me go into presentation mode. All right. So here's the link. For those of you who know how to do this, pretty straightforward, right? Basically, go to mentee.com and enter the code 48153410, and it'll be available throughout. Or if you want to just hit bang mentee, you will get the code as well. Okay, we have a few questions just to warm you up, but the idea is that towards the end, basically Artem has created a quiz, and it's not trivial, but it's not terribly difficult. You'll see that if you answer those in time and you answer them correctly, you have a chance to win swag. So with that said, let me get into the mentee. First question.
And this mentee quiz is pretty short. We're gonna, in a few minutes, we'll start talking about databases and doing our hands-on.
Perfect. Yeah. Exactly. Yeah. We don't want to spend too much time on mentee, but we know that people love mentee. So, so let's see where you're from. Perfect. We see only 22, but hopefully we can see a little bit more. I know that we have about 500 people who are out there. And for those of you, who are joining this stream for the first time, we were able to get some special permission to do more swag. So if you stick till the very end, it's not just going to be the top 3. We are probably going to have a little bit more depending on how many people are at the end of the show. Okay, so you have more chances to win swag. All right. Any comments on this? Anybody from, somebody from Brazil. That's right. Obrigado. All right. So let's go next, right? So I myself, I'm from Boston, and at this time, I keep wondering if this is the place where I want to live the rest of my life. It's pretty cold. Today it's not bad. It's 40s. But I always dream of being in another place. So which continent would you rather move to? If you're happy where you are, that's fine. Love to see that movement. A lot of people want to move to Asia. Wow. I'm happy where I am. Fantastic. A lot of people want to move to North America. That is pretty cool. Move within the continent. Yeah. I would love to go to Australia and New Zealand too. I've been to Australia and New Zealand a few times, but any comments on this, Artem? I know you're from Russia as well, right? originally.
I'm not. I'm from Ukraine.
Okay, Ukraine. Sorry. Yeah. Okay. Yeah.
Big difference.
Big difference. Agreed.
I wanted to comment that I don't see the mentee on YouTube. The mentee is not showing anything essentially on YouTube. Okay. There is no screen, so maybe you can share it or something.
Sounds good. Okay. Thank you so much.
Yeah, but speaking of countries, I did live in Russia for 3 years. So
give me a second.
Speak Russian.
Not able to figure this out. Just give me a second. I'll figure this out. My apologies here. I think I've lost the. Okay, there I am. Okay. So yeah. So you should be able to see the main monitor. Thanks for bringing that up. That's great. Okay. And let me go back to presentation mode. Now you should be able to see mentee, and you can see here a lot of people happy where you are, and that's great. But like I said, I would like to, or at least I feel like I want to move. Okay, so let me go back to present. All right, cool. Moving on. Few more questions. Have you been to any of our workshops before? This will give us an idea of who we are talking to. Okay, so that's cool. This is kind of what we expect, right? You know, a large part of our audience haven't come to the workshops before. Hopefully you'll come again. But you know, quite a few who have attended workshop before, so welcome back. All right. Any other comments, Artem? Or let's get started on the workshop, right?
Yeah, we have many new people. There are over 500 live viewers. And,
I think these are
now,
important for us to know. You know, what's your experience with relational databases? Fantastic. We have a lot of people who have more than 5 years of experience, and as you know, we are not going to be talking about relational, although your knowledge definitely helps. And you know, I'm for those of you who have never used it, or less than a year, or 1 to 3 years, you're still going to learn a lot here as well. Okay, so
yeah, for those who never use it, probably didn't use any database before.
Exactly. Yeah, more than likely, correct. Yeah, very unlikely, right? You know, you would have used a NoSQL database, but never used a relational database, right? Very unlikely. Yeah.
Very unlikely.
All right, moving on. What's your experience in NoSQL databases, right? right on cue. Okay. This is kind of what we expected, right? So I think we have the right audience. What do you think? Right?
Indeed. Yes.
This is kind of what we expected. So let's not dwell too much on this because I don't think it's going to be a total surprise. Have you used Apache Cassandra or AstroDB? If you're like, I have never heard of this, that's fine, you know. So again, kind of expected, right? Okay, that is cool. Okay, so we have like what, maybe like 10% of the people have used Apache Cassandra. So that's cool. All right, moving on. You keep this window open. We will keep asking you questions during the workshop. Okay, so just keep it open, all right? And we'll come back here again. With that said, let me move to. You're ready, Artem, to go?
Yes, I'm ready to go.
All right. Here's the agenda slide. You're good to go.
Yep. Just let me know.
You're good to go.
Yeah, sure. Yes. So let's start talking about databases, right? NoSQL is one type of database, and it's good to have a well-defined notion of what database is, right? Because we're going to talk about different types of databases. So when we say database, we usually mean one of the two things. We mean organized collection of related data items. And it's important to understand that it's organized collection. So there is some data modeling involved. You have to organize your data into tables, into JSON documents, into a graph, into key value pairs, something like that. But it's also, the data is also related to some enterprise or some application. And we will actually talk about the difference between enterprise and application. Right? What kind of databases, what's the difference between them? The other notion of a database is when we refer to database management system, and which is basically software that is able to create database, create that collection of data, manage it, store data, retrieve data. Okay, so we will be using these terms kind of interchangeably, but hopefully from the context will be easy to understand. We'll be using AstroDB, which is NoSQL database, but we'll also create a database inside of AstroDB, which will be a collection of data.
So give me a second, Artem. I will switch to full head. Give me a second. and make sure you have control. Good to go.
Good. So when we talk about databases, we usually classify them based on data model that they support. Okay, based on data model that they support. And historically, we have quite a few different data models, but I just listed here the main ones. So some of the legacy systems were navigational systems. They use hierarchical or network model and essentially a tree or a graph, but they were just the beginning of databases. They didn't have a good query language. Each time you have to retrieve data, you have to navigate that graph, literally write in code to traverse the pointers to find your information. So they were not easy to use. Then in the 70s, we had relational databases, and they're still very useful now. And there are many different organizations and applications that rely on relational databases. We will talk about many good advantages of relational databases. Then there was a movement for object databases. Why object databases? Is basically to make it easier for an application that manipulates data using objects in memory to store those objects right into database. Unfortunately, the object databases didn't become very popular, but then there were a bunch of other types of databases like XML databases, RDF databases, and then we had the movement of NoSQL, NoSQL databases. We will mostly focus on them and compare them with relational databases. We will focus on the 4 different types of NoSQL databases, which include tabular, which store data in tables just like relational. So if you're familiar with relational, you will like tabular NoSQL databases. We'll talk about document, key value, and graph as well. Okay, and of course, nowadays, many databases support multiple data models, and that's true for NoSQL, true for relational databases as well. So the relational database may support the relational model, but also may support graph or XML or JSON. And similarly for NoSQL databases, they add more and more features, and they support all kinds of different capabilities that allow you to work with different models. So we are going to use multimodal database today.
So there is a question from Shrikant, which is probably pretty appropriate. Is object databases like AWS S3? I mean, that's kind of what he's asking.
No, S3 is basically object storage. So it's not really a database in the sense that we think about transactions, we think about query language and things like that.
Sure.
So one more point here I wanted to make is for relational databases, I also have these 2 bullets for row-oriented and column-oriented or columnar. So essentially, this will be true for any tabular databases. So for example, NoSQL tabular databases, they also have rows and columns, and they can be row-oriented or column-oriented. Essentially, this is a storage model, how database stores those rows and columns. If it stores all the data in a row together, then it is row-oriented database, and it's great for real-time transaction processing. So it's called OLTP type of system, and we're going to use OLTP database today. But also column-oriented or columnar, they basically store all values in a column from different rows together, so that they can be retrieved together and analyzed quickly. And these are OLAP systems usually, so they are for analytical processing. They have slow response, but they usually process more data. And besides relational databases, there are some NoSQL databases that are column-oriented. There are also modern data warehouses. They are column-oriented, like BigQuery and Snowflake. Okay, so by deployment model, we can differentiate these types of databases, single machine databases and databases that works on clusters, and these are distributed databases. So they partition data and store on different nodes with replication, and there can be multiple data centers that are distributed geographically. They can live in different locations. So which is good for reliability and availability. Also, databases can be run on premises and they can be in cloud. So nowadays we have more and more push towards cloud, a lot of migration. And in the cloud, you can use either just virtual machine, you install your database software, and you are responsible for managing that. Or another kind of deployment is database as a service, where the database is already pre-installed for you, it already runs, already configured, and you just, there are two types of those services. Managed service, where you basically specify how many nodes you want to have in that database cluster, and basically you go with that number, and you can later maybe increase it manually or decrease it manually. But the best type of those database as a service that offerings are serverless and auto-scalable database services, where you do not really worry about how many instances you will use, how many nodes you will need in the cluster. So the system, the service takes care of that. And if the number of transactions, the throughput increases, the service will add nodes to that cluster automatically. When the workload decreases, then the number of nodes decreases as well automatically. And essentially, you do the least amount of management operations with this service, and you actually pay less for doing less, for working less, because you're paying less because it's auto-scalable. If you don't have a lot of transactions, workload is low, then you will not need to pay for running 1,000 node cluster. It will be scaled down to 10 nodes, for example. Okay.
Is it worth noting here that data on the cloud is still relatively new? I'm not saying that it's brand new, but I come from the cloud foundry side of the world, and essentially what happens there is it's really more about 12-factor apps, where it's more about stateless, but stateful apps are relatively new, and in the last 5 or 6 years, and managing them is a little bit is a little bit different as compared to stateless or stateless apps.
Yes, indeed, and we're gonna actually use a cutting edge database, serverless database today. In many aspects, it's a unique serverless database. There are no other databases that have the same characteristics. Okay, so why not relation? Why not? So let's talk about just understand the benefits of relationals and the problems that may exist with relational databases. So what we like about relational databases, and that's why they became so popular, is standardization and theoretical, very solid theoretical foundation, right? There is a relational data model, there is relational algebra and calculus, when we usually don't care about that, but people who write, do query optimizations, write those optimizers, they do care about those things, definitely, because that's what they work with. And even some NoSQL databases and big data framework, big data processing framework like Spark, they also rely on things like relational algebra to optimize the execution of those Spark. Okay. Also, there is normalization theory. We will mention normalization, denormalization a couple of times today. And there is a structured query language, SQL, that we all heard about it. Some of us use it and know, and still there are many applications and use cases where we will prefer SQL to NoSQL. Then there are also ACID transactions that allow us to have atomic, consistent, isolated, and durable transactions. But they kind of expensive, right? To use if you, especially if you have many concurrent transactions. And also relational databases are usually used as integration databases shared by many applications. So in other words, you have the single source of truth, you normalize your tables, you store data once, you do not duplicate it, and many applications use that database. Okay, that's how relational are usually modeled and used. Then the cons would be that relational databases are originally designed for a single machine, and they scale vertically, basically increasing the number of resources, amount of resources on one single server. And at that time, that was pretty good, but things have changed since then, since 1970s, right? So another disadvantage is impedance mismatch between the relational data model and application in-memory data structure. We mentioned that already. There exist relational to object to relational mappings to solve that problem. But essentially, yeah, in your application, you do not manipulate tables and rows. In database, you do, but in your application, you have objects. Okay, so why NoSQL? Relational databases have many advantages, but at some point in the beginning of the century, we had the explosive growth of data, new high growth challenges. That data had to be processed, that had to be stored. There could be many points of collection of that data, and it has to be collected fast, and the data can also be in different formats, so there is a variety there. So you maybe heard about big data and CVs, which is volume, large amounts, massive amounts of data, velocity, speed of consuming that data, storing it into database, and variety using different formats. But the main reason why NoSQL databases came to existence is because relational databases lacked performance and scalability in this new environment where you had to store petabytes of data, right? Petabytes of data. And those databases also needed to scale. NoSQL database needed to scale horizontally rather than vertically on clusters. So here we have, on this graph, we have the size or volume of data created and replicated worldwide. And it's in zettabytes. 1 zettabyte is 1 million petabytes. Yeah, it's quite big. But essentially, you can see in 2010s, we have this zettabyte error started, and it keeps growing, right? So, and the relational databases have difficulty scaling to these sizes. So what origins of term NoSQL, this sometimes can be controversial topic, but essentially that was the name of the meetup and also catchy hashtag that intended to refer to databases like Bigtable and DynamoDB from Google and Amazon, respectively. So meetup was in 2009 in San Francisco. The presentations were on Cassandra, MongoDB, CouchDB, HBase, and so forth. And we are actually going to mention those. We are going to use one of those, and we're going to mention talk about the other 4. Okay. Sometimes we can also find the node-only SQL interpretation today, but again, may not be very descriptive because relational databases, they support not only SQL, they can support other languages as well. If you look at databases, relational databases like Oracle. So what is really NoSQL? It's a database that can meet high growth challenges. We talk about the performance and scalability, so that we can store and create massive data sets. Okay, and those databases commonly have these characteristics. It's not necessarily that each NoSQL database will have all of them, but probably most of them. Okay, so they have they use non-relational data model because relational is hard to scale on a cluster horizontally, right? The non-relational data models, they run on clusters of servers. They can be globally, geographically distributed, different data centers in different countries, different continents. They support high throughput, many transactions, real-time transactions per second, millions of them. They scale horizontally and preferably linearly. So if the number of transactions that you need to handle doubles, then you simply double the size of your cluster. You add twice as many nodes to be able to handle that increased volume of transactions. They frequently open source or based on open source, but there can be, of course, some proprietary systems, and they frequently bound by the CAP theorem, and not always. Some of them that may be even famous NoSQL databases in graph space in particular may not be fully distributed and may not comply with the CAP theorem. We will talk about CAP theorem shortly. So relational versus NoSQL. Let's compare these two. Relational provides standard relational model and language SQL. NoSQL provides variety of data models and languages. Then we have ACID transactions for relational. We have lower guarantee transactions for NoSQL because because of performance. Yeah, the ACID transactions and two-phase are expensive. We have integration database on the relational side. On NoSQL side, we have application databases. So we design NoSQL database. We model our data specific to one application. We do not usually support 5 applications on the same set of tables or same set of JSON documents and so on. So data modeling is specific to application. Relational design for single machine, NoSQL design for cluster right away. Relational hard to scale, they scale vertically. NoSQL easy to scale and cost effective, they scale horizontally. Relational have impedance mismatch. NoSQL have better compatibility between database and application data models. So on this image here, you see that relational scales vertically, NoSQL scales horizontally. So let's talk about CAP theorem, and we will do very shortly. We will have the first hands-on, and we'll and NoSQL. We'll use NoSQL database system to create our first database.
Why is NoSQL popular amongst kind of like the big companies like Apple, LinkedIn, a lot of places, Facebook, where it originated? Is it primarily because of the horizontal scaling aspect of it? Because with a single database, you can scale it up and up only to a certain degree. After that, it's just going to fall over and die, right? Is that one of the reasons, or are there a variety of reasons? Maybe you're getting to that.
Well, the main reason is performance and scalability.
I think linear scalability.
That's the main reason. Yeah, if relational databases could have handled that amount of data, there was no motivation to create something new. In that case, but the main is, of course, scalability. It's horizontal scalability. You hear about 1,000 node clusters for NoSQL databases, like for example, Apple running Cassandra with using many thousands of servers, but usually don't hear that for relational databases, right? You don't hear about 1,000 node server relational database serving some application. So use cases changed. Those 3V big data requirements changed, and we had to solve the problem differently. Okay, so going back to the CAP theorem, the CAP theorem applies to distributed data storage systems, distributed databases. And it basically states that out of these three properties, a distributed database can only provide two guarantees, two properties. So it can be available and partition tolerant, or it can be consistent and partition tolerant. Usually not consistent and available at the same time. I will talk about it shortly. So what are those properties? So you can only pick two for distributed database. The properties: consistency, every read receives the most recent write, or an error. So why are we talking about most recent write and all of that? Because when we're writing data into distributed database, it will go to several nodes that are replicate the data, and some of them will store the data in a few milliseconds, and maybe one replica will have a lag and will store it in 20 milliseconds. So when you read data, with consistency, you guarantee that you will read the most recent one, or there will be an error. An error means the system is currently not available to respond. So that's why you kind of going to select between consistency and availability. Availability refers to the system always responds, but may not always return the most recent write. So it's always available, always gives you the result, but may be inconsistent result. And then partition tolerance operates in the presence of network partition failures. If node goes down, if the whole data center is not communicating with a different data center, you still can operate. So because these are distributed databases, you basically have to choose partition tolerance. If you have 1,000 nodes in your cluster, if one goes down, you still want to operate, and one will go down for sure because it's a large cluster. So you always basically select partition tolerance, and then you pick either consistency or availability, whatever is more important to you. And you usually, so for the reason of, because these are distributed databases, you do not pick consistency and availability at the same time, because if just one server goes down, you lose the whole system. That doesn't work in distributed environment. So here's some
Artem,
examples of those
again,
most.
To talk about the CAP theorem, I think you can have all three, in like a working scenario when there are no failures and all that, which never happens in distributed system. Completely get that. But when a failure occurs, you can pick only two of the three. Correct? That something that makes sense. Yeah.
That's right. That's right. That's correct. And nowadays this distinction actually between CP AP system can also be blurred. So many systems they can actually tune your consistency and trade it for availability and vice versa. So you can actually have a system that can withstand multiple nodes and even data center failure, but may still
at this
stay
point, I
consistent.
think Mickey Glory, great glorious name, has a great question, which is like, is NoSQL and transactions kind of mutually exclusive? In other words, with NoSQL, can you also achieve transactions? I know Stefano already responded to that, but if you want to add your thoughts, that'd be great.
Yeah, so you can, but you may have them implemented in the database, or they may already exist there, or you may have to add them or add some kind of transaction processing framework. But just understand the reason why are usually not there is because of they are complex, and they will not be performant enough for NoSQL database to support the requirements that we talked about. So in systems like Cassandra and AstroDB, and actually many others, there are lightweight transactions that use Paxos protocol, which doesn't guarantee ACID, but it guarantees some lower lower. It has some lower guarantees for transactions.
And acid for
Okay,
those who
but
are
just
completely
understand.
uninitiated, not to insult anybody's intelligence here, is atomicity, consistency, isolation, and durability. That's the typical properties associated with the transaction.
Yeah, but just understand that transaction processing is kind of a separate from the database itself. You can add transaction processing on top of a database. So they can, but in many use cases, with NoSQL, we think differently, and we kind of do things differently so that we don't need ACID properties. And unfortunately, that's a big topic, and I will not be able to cover it right now. So we will stay focused on our introduction to NoSQL databases. So what we're going to use today is state-of-the-art NoSQL database called AstroDB. It's a database as a service. You don't need to install anything. It's serverless. It's auto-scalable. So you don't need to specify how many nodes in the cluster you will have. It will scale. It will become a larger cluster or a smaller cluster based on your workload. It's going to be free for you to use. It's a multi-cloud. It will run in AWS. It will run in Google Cloud or Azure. It's distributed behind under the hood. There will be multi-node cluster, of course, and essentially, actually, 1,000-node cluster that will handle multiple tenants, and you will just be using 3 of those nodes and things like that. It's a NoSQL, it's multimodal, it supports tabular, document, and key value. We're going to use this database for all 3 of those types, and it's based on open source Apache Cassandra. It has linear scalability, high availability, can serve high throughput applications, and so on. So this is one of the best and unique. So this is actually the first serverless database service which is based on open source.
And one of the cool things is, like you said, multi-region, disaster recovery, any of those, you don't need to worry, because we kind of take care of that for you. You may not get it in the free tier, so
Yes.
but you can definitely get it if you want. Okay, so you may have to put in a credit card, or you may have to get a license or something like that, and we'll talk about that.
Yep. Yeah, and this database is going to be free for you. You don't need to enter a credit card or anything. You just need to register. You get 25 monthly credit. $25 doesn't seem like a lot, but it's enough to actually run millions and millions of read and write operations. So definitely, I'm not going to use even a single dollar today from that. And we will use, for our hands-on, we will use different web-based tools, SQL console to work with tabular databases using SQL. SQL is a Cassandra query language, similar to it's like very similar, has very similar syntax to SQL. We'll use Swagger UI to work with REST API and document JSON API. And we will also use GraphQL Playground, which is another web application, web client that allows you to work with GraphQL API. Okay, and with that, Rex is gonna help you with setting up your first database, or you can just watch me doing it as a demo.
All right, let me go to my screen, and the place to get started is just hit pound or exclamation GitHub, okay, in chat, and it'll point you to this repository, okay, which is GitHub DataStax Devs Workshop Introduction to NoSQL. All our workshops, are on GitHub, and you can just follow along. They are primarily intended to kind of do it yourself, kind of a self-help, but you can watch the recording as well, whatever suits your fancy, okay. So this is all that I do, really. I go to this GitHub link, and then kind of follow along. Very easy to follow along instructions. The first thing that it's gonna, and I think Artem already talked about this. Astra is the simplest way to run Cassandra. One of the criticisms about Astra, or rather Cassandra, was that it was, it's cool. It's linearly scalable. It's not easy to set up, right? So with this, you don't really need anything. You don't even need a credit card. And like what Artem was saying, you can do 20 million reads and writes, as it says here, and about 80 gigabytes storage free per month. Enough to run some fairly sophisticated production workloads. Okay, so let me go into full screen mode and see if you can see that in better. Okay. So that's all I'm going to do. I'm just going to follow along. Take your time. You're going to create a database and a key space called NoSQL 1. Okay. All that you're going to do is you're going to click on this. Okay. And I'm just going to click on this and say open link in new window. Okay. And it will take you to this particular screen. Okay. Which is basically a registration. All that you need to do is put your email and your password. Okay. Because I've been here before. It knows me, and I can put it in, right? But I'm not going to do that. So once you actually, let me do that anyway. All right, open link in new window, okay, and then I just sign in. Okay. So the first time around, you may have to sign up. It may ask you a few questions about what kind of what kind of profile you are. Are you more a developer? That kind of information. And then it'll bring you into this dashboard. Okay. So essentially, I have like 5 databases here and a bunch of key spaces in there, right? So what as the instruction said, right? You just go into workshops, right? And then create a key space. To be able to create a database, you just click on create database. I'm not going to go through that here, but I believe it's, correct me if I'm wrong, Artem, workshops, and the key space is
the key space is NoSQL 1.
I've already done this, so I'm not going to go through this, but you can pick any region, any provider. If some of those regions are not available and you particularly want that region for whatever reason, you can just go on chat and ask our folks to help you out. They will be able to help you out. Or if you put a credit card, money always talks, right? You can create it in whatever region you want. For now, what we recommend is just use the region closest to you. I live in North America. I live in Boston, like I said, and either I pick the South Carolina, Moncks Corner, or the Virginia, Ashburn. Okay, Ashburn, Virginia, one. I mean, really, you can pick anything you want. Actually, Montreal is probably the closest to me, so I could pick this too. It doesn't really matter. Okay. See, like I said, there are some regions which are locked. So if you want to unlock it, you can do that if you want. But just pick something that's available, and then once you pick the workshops, right? And NoSQL 1.
Yeah. You may need to use GCP.
Correct. Yeah,
only
because the other regions are locked. Okay. So what you can do is you can just pick this and then hit the create database, and the database will be created for you. Okay. So once you create the database, okay, let me get out of this. You're again going to be presented, something like this. You will see your new database in pending or initializing on the dashboard. What we want to do is we want to make sure that you have set up the database and good to go. If you've already attended our workshops before, chances are that you've already created a database. All that you need to do is make sure that it comes up. And the best way to do it is just go back into connect mode or something like that, and I can show that to you in a second. So basically, if I go back into okay. So I'm already signed in, right? And you can see here, there are some of these in standby mode, right? So let's say I want to activate this demos, okay? It really doesn't matter, or workshops is already in active mode, so it doesn't matter. So you can just hit connect, and you can just hit like a SQL console or something, and hopefully it should tell you that it's resuming your database. And if you go back, you'll find it. But if you're here for the first time, no worries. All that you're going to do is you're going to hit the create database, pick the region, make sure you have the workshops in the workshop and NoSQL one in the key space. So workshops in the database and NoSQL one in the key space, and then you're good to go. Okay. So let's see some thumbs up of people. If it's still pending, that's fine. And then we can kind of go from there. All right. Let's see some thumbs up. We generally tend to make sure that we do a periodic check to make sure that everybody is good.
Yeah, so what we are doing here is just creating an empty database inside of AstroDB, and later we will create some data there that will be either tabular or key value or document. So we will use 3 different types of data models to demonstrate how NoSQL can handle those. Because AstroDB is a multimodal database, we can do that. And if you have time for graph databases for the demo, we will use a different system for that. But right now you just simply need to create a database, and it will take, so the message you are getting, Rags, there in SQL console, basically saying that we're still initializing the database.
Actually, basically what it was in hibernation mode, because what we do is we try to basically save some dollars, right? And that's why we hibernate and keep it ready. But if you're creating brand new, it'll start in pending, and then it'll go into active state. Okay, and you'll see that. So we see a lot of thumbs up. That is pretty cool. Was I supposed to go to the tabular database, or is it? Okay,
yeah, well,
just give me a second. I will
give
you this control back. All right, you're good to go, sir.
So, so what you just did is created that database in AstroDB, and Astra itself is a platform. Currently has 2 services: the AstroDB database as a service, and also Astra Streaming as a service. AstroDB is based on Cassandra, which is Apache Cassandra open source, and it supports many different APIs. We will use several of them today. And if you're interested in streaming, then Astra Streaming supports is based on Apache Pulsar, and it's also compatible with a number of systems like Kafka. Maybe you heard about it. So that's something that you may be interested in exploring in the future. But today we're going to focus on these 4 types of NoSQL databases. We use tabular. We'll create tabular database. We'll create document database, key value database, all in AstroDB, and we can also do the graph database using DataStax graph. Or if we don't have enough time, then we will leave it as a homework. Okay, so running example. So I'm going to demonstrate you how those data models work. And the running example is entity relationship model here, which has, it's very simple. User can have multiple accounts, and accounts can belong to, they always assign an account assigned to one user. User is uniquely identified by ID, has name and email. Account is uniquely identified by ID, has type and balance. So people familiar with relational databases should feel right at home here. We use this example with basically two users, Alice with email, that particular email, and Bob, and Alice will have 2 accounts, checking and savings, with balances 2,500, 1,500 in some currency, and Bob will have only checking account. So how will this look like in relational database first, right? So for relational database, there is another ER small diagram here, which basically, which is a different, little bit different notation. It's now includes foreign keys, primary keys. So we have users table with primary key user ID, accounts table with primary key account ID, and user ID is also added into accounts table. It's a foreign key which references user. This is how the relational database would store. And whenever you need to retrieve accounts of Alice, you will have to join users and accounts using user ID column, right? So there will be join involved there to retrieve that data. So our question, big question, actually 4 questions. How are we gonna store the same data using tabular NoSQL, using document JSON, using key value, and using graph? And this is what we're gonna talk for each of those types. We're gonna use the same example, starting with tabular. So what is tabular databases? Some examples include Cassandra, AstroDB, and Bigtable, and Apache HBase. So tabular databases use tables with columns and rows, should be quite familiar. They are closest in similarity to relational databases. However, they do not normalize tables. They use denormalized tables that are designed based on queries that they need to support. Another difference, besides the prime key in a table, they do not have foreign keys, but a partition key and cluster, sometimes called sorting key. And essentially, the primary key consists of partition key and clustering key, where partition key defines how to distribute data. So it defines a partition, and partition can contain multiple rows, and those rows will be stored together on some server and replicas. And clustering key basically defines the sorting of those rows within a partition. So in this example, we have user ID, account ID. So user ID is a partition key, account ID is a clustering key, and together they form primary key in Cassandra or AstroDB. And you can see that basically user ID alone cannot be a primary key. It doesn't find uniqueness here, right? Because there is a repetition. But together with account ID, they can form unique primary key. Okay, in terms of querying tabular databases, you can retrieve very efficiently. You can retrieve one row from a partition, subset of rows, or even all rows in a partition. So retrieve one partition. So this is done based again on primary key, partition key, clustering key. And but there are of course secondary indexes, materialized views if you need them, and the language, and there are lightweight transactions, and the languages that are used to query are usually SQL-like. They have select from where, just shown here. This is Cassandra query language, where we select account type, account balance from accounts by users table. It should be account by user table, where user ID equals something. Okay. These databases usually do not support joins, but you can add them. You can, first of all, if you understand how joins work well, you may be able to do something in the application itself. But there are other frameworks you can add, like again Spark SQL, for example, that you can add joins, but they still will not be super efficient. So they are not for OLTP transactions, real-time processing. Use cases. This is a general purpose database. It basically handles many cases that relational databases do, but those use cases where you actually need scale and performance. Okay, so transaction processing, IoT, time series, messaging, activity tracking, content, e-commerce, and so on and so on. So there are basically all types of different industries will have an application nowadays, because we collect more and more data for each individual person, for transactions and so on. Okay, so running example, how are we gonna present that data that we had for Alice and Bob? So here we have kind of a schematic definition of the table, accounts by user, with user ID as a partition key, account ID is a clustering key, and you can see there is arrow, so it's sorted. Okay, and then account type, account balance, just regular columns, username and user email are static columns. Okay, static columns doesn't mean that they cannot be changed. It means that these columns belong to partition. They are shared by all rows in the partition. So what I mean by that, you can see there is a user Alice here who actually has two different rows in this partition. So user ID defines a partition and account ID defines a row within a partition. So there are two rows in this partition, and you can efficiently retrieve both of them because they will be collocated, stored together. For Bob, we only have one row, but you can see this static column Alice and email. These columns basically belong to partition rather than individual rows. So what you may have noticed here, we only needed one table here, right? And we didn't do much duplication, denormalization that we usually talk about when we talk about NoSQL, because it doesn't always have to be a lot of duplication and denormalization. So what this table was designed for is to support specific query. Retrieve all accounts for a particular user. Okay, all accounts for a particular user. It can do it very efficiently. So no two tables, just one table. There will be no joins because we do not support joins. And with that said, we have second hands-on where you can actually create a couple of tables in AstroDB.
Oh, okay. Before we jump into the hands-on, I know there was a question from Programmer's Way. What is the key space? Really, a key space is a logical container, if you want to think about it that way, where you kind of group tables together. So that's really what a key space really means. I don't know if you want to add more color on that, and I will get to that in a second. But there are other things that I think you alluded to, like for example joins, right? We have a saying within DataStax which is like, friends don't let friends shard. I think Artem talked about like partition key and several different keys. Typically from a SQL world, from a relational world, you're aware of primary key, but in the NoSQL world, actually the partition key is very critical because that is how the data is distributed. If you want to think about data being distributed across different nodes and all that, it's based on the partition key. And then within the partition, you have the clustering key that Artem talked about. We have an entire workshop, devoted for that. So we won't have too much time to talk about that. But if you want to add a little bit color, Artem, feel free, and I will set myself up for the next exercise.
Yeah, so this is just introduction. We had 2 slides on tabular. That's not enough to become like a super fluent in tabular databases in NoSQL, also wide column data model. So, but what you can notice is you're still using tables, you're still using columns and rows, but there is a primary key, but there is also partition key and clustering key. And what Rex said is true, and it's right, but we will need much more time to explain them better, how partition key does how it affects data distribution, how clustering key can be used for sorting and for guaranteeing uniqueness of a primary key and all of that. So for now, just realize that it's just a table. It's just like a relational with a few important differences. So one other things I wanted to mention here, the user ID and account, they may look strange. These are so-called universally unique identifiers. They are generated automatically by the system, by an application. The reason why you want to use UUIDs, universally unique identifiers, because this is distributed system. You cannot just do like auto increment or something like that in relational.
Perfect. So again, okay. I know that you guys can't wait to get your hands dirty, right? Go back to same GitHub link. If you don't know where the GitHub link is, just hit exclamation GitHub, and you should be, the first question that it's going to tell you, the first answer to your question is going to be, what is your key space? Is key space, as you can see, is a logical grouping of tables. Okay, so let's go and visualize this using what is referred to as the SQL, which is the Cassandra query language console. Okay, and it walks you through each of this step very clearly. Okay, so you're going to click on workshops, which is your database. Okay, and then click on SQL console, which is the console, and it brings you into something like this, which kind of looks like this. Okay, and then what you're going to do is you're going to use NoSQL 1 and then start creating your tables. Okay, so let's do this one step at a time, right? So let me click on workshops. Okay, and then what I can do is you can hit connect. Okay, and hit SQL console. All right, and this should bring you in here. Okay, and what you can do is you can just do a describe. Okay, and I've already created this, so it might be a little different for you, but if you just do a describe key spaces, you will see here, I have a bunch of stuff here. Okay, this was for last week's workshop. I have some for tomorrow that I'm getting ready for, but this is the key space that you're going to use. Okay, the NoSQL 1. And actually, if you have not created it before, you will create it. Very simple, use NoSQL and then start creating the table if it does not exist. And it's always a good idea. It's always a best practice to create a table only if it does not exist, right? So that you're not going to overwrite something that's already there. Always a good idea to do that. Okay. So now let me go in and describe the key space NoSQL 1. And again, all that I do is take this from the instructions and put it in there. Okay. So if you hover over here, you will see like cut and paste, and you're gonna grab that and use that here. Okay. So if you describe the key space, okay, it will tell you what kind of it'll give you more information on the key space. Okay, so there are different tables that have already been created. The first time around, you probably won't have any, so you don't need to worry too much about that. So you will see something like your expected output will look something like this, right? You just have just the videos, the videos table, okay, and you have the video ID is the primary key, right? And then you have text. You have a list of integers, which are frames, and then you have tags, which is a set of integers, and so on and so forth. Okay, and you will see here, that essentially the partitioning is going to be based on the video ID. Okay. So what you can do is just again basically grab from here and go into your SQL console. Okay, and again, if you can wait for a little bit and not get started, listen to me for a little bit, and after that we'll turn you loose, and then you can give us some thumbs up once you're ready. Okay, so now what I'm going to do is I'm going to go to the next step, which is really what I'm doing is I'm inserting some entries on my first table. I mean, I've already inserted this, so hopefully it should work fine. Okay, key space has not been defined, so use NoSQL 1, right? Because I didn't use the key space, it gave me an error. So just do the same thing now, and you will see that it's been inserted. Okay. So once it's inserted, we don't recommend this for actual production, because when you say select star from videos, you're actually going to each of those different partitions and pulling data together. It's always better, always recommended to go to a partition and get the data from there rather than go to every partition, right? So typically what you would do is you would select star from the table and specify the primary key. Okay, like for example, you will see right here, select star from videos, where video ID is equal to whatever. And now the video ID, essentially, as we call it, is hashed into a particular partition, and from that particular partition, you're going to get the information. Okay, but since we are learning here, we are still in learning mode, right? We are probably okay to do this, right? So you can see here, I've already created a bunch of entries here, and you'll see all the entries: video ID, email, frames, tags. You can pick and choose. This is kind of somewhat similar to SQL if you have used this before, but obviously there are some critical differences as well. Okay, so now what I'm going to do is I'm going to go to a one partition, right, and I'm going to pull the data from there. So this is what I'm doing. Select star from videos where, select all the table, I mean all the columns, right? From this particular table where I'm going to a particular partition, hitting the partition and getting the data from there. And there you go, okay? So this is a lot, it's a better practice to observe, because that's typically how NoSQL works. Is you have the case, the use cases kind of defined by the primary key or the partition key, so that you don't do a whole lot of looking around the entire cluster, but you go to a specific partition. Okay. Now, obviously, based on your use cases, you may want to create new tables, right? So again, the same formula, right? If it does not exist, then you create. So what you're doing here is you probably want to kind of look through the users by city. Okay, so create table if not exists, and notice here my primary key is based on city, and then you have a last name and email, which are really the clustering key. And now what you can do is you can if you're producing a report, you can produce a report where the last name is ascending, but if you want it descending, you can do that as well. You can do that in the query. But essentially, what this does, there are a number of rules for primary key, clustering key, and so on. But the idea is that you let your use cases define your keys rather than the other way around. In the typical SQL world, what you do is you kind of adjust your use cases based on the data model, which is really not the ideal way to go. You would rather the use cases define the data model. Okay. So I think I've said enough, but let's take one look at this select star from users by city, where city is equal to Paris, right? Same thing again. You're going to do the same thing, right? Select star from users by city, where city is equal to Paris, right? And you should see a couple of those. Okay. So let's again see a few thumbs up after you get to this. This is probably going to take a little bit longer, so we will be a little bit more patient. I know that I think we're doing reasonably okay with respect to time. But Artem, do you want to add any color here? Did I miss anything major?
We had a few questions, and I'm gonna answer them. They're basically questions about where do we get these scripts and instructions. They are on GitHub. We posted that link multiple times, and somebody will post it again. Rags was switching between the instructions on GitHub and the AstroDB interface in particular SQL console, which is in that case web client that supports.
No, that's a great point. I think I didn't mention that. Basically what you can see this better now. I have this in two different tabs. One tab is my GitHub instructions, and the other tab is my Astro database. And essentially what I've done is I did a connect. I clicked on the workshops, the database, and then I did a connect, and then I hit SQL console, and then I'm good to go here. Okay. And then what you do is you use the key space. Okay, and you can do a whole bunch of stuff. I'm just going to describe the tables here. Okay, and you'll see here there are different ones: key value, users by city, videos, column 1, and so on and so on. Okay. All right. Yeah, go ahead.
So another question: if somebody is following these instructions and doing the hands-on, do they need to take screenshots for the homework, submit as a homework?
Not at the moment, and again, this is not going to take too long. So different people learn differently, right? I like to kind of go through it once and then go back again and then take screenshots. It's just easier. Whatever style works for you, that's fine.
Yeah, if somebody got lost, you can just look at the demo, and then as a homework, you can follow those instructions. They work. So if you just follow them properly, you should be able to do this same work. So there should be no errors.
All right. Back to you, Artem.
Yes.
You're good to go.
Yeah, so the next one we're going to look at is document database. And what are those document databases? Examples are MongoDB, Couchbase, and AstroDB. Okay, and the data model is essentially a semi-structured document. Usually it's in JSON format, so most common. It can be some other format, XML, for example, or something else. But JSON is the most common, very convenient, and we're going to use JSON. These databases are sometimes called schemaless, but it's so as if they do not have schema, but that's more of a marketing term. They do have schema, definitely, because otherwise how are you going to process that data? How are you going to query? No, there are fields there inside of JSON. There are even data types like array data types and things like that. So the schema is actually, you don't need to define the schema in advance. You can store your data, but it's already organized and structured in JSON document, and you actually data model in advance, and you think how you're gonna retrieve that data, how you're gonna organize it, how you're gonna use it in your application. So when you read that data back, that's when you process it, and it's basically like schema on read, schema embedded into the document itself. That structure of the document is the schema. So those JSON documents usually have IDs. IDs can be generated automatically by the system, and you may never need to use that ID. But you can also specify your own ID if you prefer and use it in your application. That will be very efficient access pattern. But the difference, however, the document databases frequently use queries that basically retrieve potential multiple documents based on fields inside of the document. So they use a lot of indexing schemes that allows you to query fields inside of those JSON documents. Okay, so these are query access patterns. Also, those JSON documents are usually organized, so a number of them can be stored into container, which is called a collection. So here in this illustration, we have users, which is a collection of JSON documents, and one of them has ID A, the other one has ID B, something like that. But here are a couple of examples of kind of what types of queries you can use. In MongoDB, here we're using database collection users. We find all JSON documents where there is a field name with value Alice. In AstroDB, the same will look like this. So this is the REST API. We're going to get and document API at the same time. We're going to get namespaces. Namespaces basically like a key space, banking, and then collection users, and then where name equals Alice. Okay, so the use cases for document databases will benefit anything that benefits with less structured, semi-structured data. So it's more flexible schema. So mobile applications that will evolve frequently, maybe gaming applications, some catalogs of data, content management, and so on. But essentially, you nest a lot of relevant data into that JSON document, you store it, and then you index it, and you will be able to query based on different fields or document IDs. So how does, for our running example, how does document model looks like? We have JSON document for Bob, and we have JSON document for Alice, and you can see there is ID of Alice, there is name, there is email, there are 2 accounts, there is array with 2 accounts that have ID, type, and balance. And we can, and the system automatically indexes those fields, and you can query based on name and email, or the system also automatically assigns ID, or you can specify what kind of ID you want for the whole document so that you can efficiently retrieve it. Again, we are not looking at the joins here, just there are no two tables. There is one collection of those JSON documents for users, and there are two JSON documents stored. And do we have any questions?
Yeah, good question. I want to bring up something that I forgot to mention in the previous, and maybe the best way to do that is to just show this to you. I know that some of you are struggling with the key space. I mean, not all of you, but some of you. If you have already created a database called workshops, right? Chances are, you'll see it on the left side, and then make sure that it's active. And once it's active, all that you need to do is you can just say add a key space. Okay, if the workshop is then what you can do is you can put NoSQL1. So if you find that the key space is not there, okay, chances are that you've already created the database. If you're brand new to this, no big deal. Everything will work like in the instructions. But if you have been to our past workshops, we ask you to create a new database. And typically, we use workshops. You will need to add this. So here you're going to put NoSQL1, which is the key space. And here it's taken because, the key space is already taken. But in your case, if it's not there, you will add it. One other thing, just use the case as is, because there are ways in working around it, but it's just easier to use the case as is. Okay. So with that said, let me jump to the next part, which is really the exciting part, right? I think Artem talked about JSON, so I don't know why JSON is exciting, but it is, right? So again, what I'm going to do is I'm going to go to workshops, right? No big deal, right? Connect, and then I'm going to hit on SQL console, right? And use NoSQL1, right? And again, I cut from the instructions and I pasted it, right? That's all I did. So what I'm doing here is, remember I inserted into videos and it was not in JSON format, right? But here it's in JSON format, okay? So sometimes it's easier, especially if you're doing some programming and things like that, to insert JSON directly. But, if you want to insert data, that's fine as well. Okay, so you can try that out. Okay, and if you want to see the JSON, you can do that as well. All right, so here you can see the information. Remember it was all in columns right before, but now here it's in JSON. So if I just do select, I believe this should work, right? So you'll see only as columns, but here you'll see it as JSON. Now the next part is a very critical part, and I appreciate if you can pay some attention here, because this is probably the most complex part of the workshop, even though it's pretty straightforward. Okay, so what you need to do to be able to get access is to have what is referred to as a token. Okay, and this is typically how a lot of the APIs, REST-based APIs work. Okay, so what you can do is you can generate a token. The steps are in there. So you do a generate token, okay, and basically pick a database administrator as the role, okay, and then what you do is you do a click to copy, okay. Typically what I do is I take this and paste it somewhere so that I can always have access to this token, and you're going to probably use this token throughout this workshop today. So that's my suggestion. So again, what you're going to do is you're going to pick the database administrator role, and then you're going to get something, a page that looks like this. Okay, so let me show it to you in action. Okay, because you can always create one. So there are a number of different ways of doing this. Basically, what I do is I go into here, manage organizations. No, I don't want to do that. So organization settings, right? And then I go to token management and generate a new token. Okay, so token management. And then what you can do is you can enter a description if you want, but pick the database administrator, right? And when you hit a generate token, okay, you will see something like this. So what you can do is you can grab this. The only note of caution here is if you wander away from this tab, or from this page, you are not going to be able to get back to this. So make sure that you copy the token before you wander away, or if you, for some reason, you wandered away, you probably will have to create a new token anyway. Okay. So with that said, let's get some thumbs up of when you have copied the tokens, and then we can proceed from there. How about we take a brief little pause? I know we are kind of running up on time, right? Yeah.
We're running out of time soon, so I suggest we just do demos, and you can do homework if you prefer. So you have exactly the same instruction.
Yeah. So not to worry at all. Okay. So what we're gonna do next? Maybe if I see some couple of thumbs up of people able to copy the token, then we can proceed. I just don't want to leave everybody behind, right? But like what Artem, I think it might be a good idea to just kind of proceed. Okay, so next what we're going to do, okay, couple of thumbs up is all I want. Okay, so next what we're going to do is we're going to locate the Swagger URL here. Okay, so let's see, go back here. Okay, I have copied the token, so I'm not going to worry too much about that. So I'm going to go back to my dashboard. Okay, and I am worried about workshops, right? And what I'm going to do is I'm going to do the connect again. Okay, and you should see somewhere here there is a Swagger URL somewhere in between, right? Launching the Swagger UI. So just click on that. If you want to click on that new window, you can do that as well. Whatever suits your fancy. Okay, so just click on this. Okay, and it will bring you to a new tab, which is basically the Swagger of all the APIs that are available for you. And we're going to try some of them. Okay, I'm not going to go through all of them because I don't think we have the time for that. Locate the documents section in the Swagger UI, right? So let's go back to locate the documents. And essentially, actually, we are going to take a look at all the, or we're going to create a new empty collection. Okay, yeah, I think that's good. We'll create a new collection. I was just wondering if there is, actually, let me show you something a little bit more easier. So what I'm going to do is I'm going to get all the namespaces in this particular key space. Okay, so all that you're going to do is you're going to click on it. You're going to do a try it out, right? And you're going to hit an execute. Okay, and if you hit an execute, you're going to get an error because don't have the token there, right? So what I'm going to do is I'm going to grab the token. Okay, and I basically destroy this after this. So I'm going to go back. Okay, and I'm going to put the token. Oh, that's the wrong one. I did not grab it properly. So let me grab it properly. Okay, and go back here, put the token, and now I should be able to execute. Okay, and you'll see here, it's the same information that you got before, right? You got system auth, you had to-dos, you had the to-do list, all the different key spaces, in that particular database, right? So all the different key spaces are available, and you can dig into each of those key spaces. So let's create a collection like it suggested, and then maybe I can skip the other ones. Okay, so create an empty collection. So how do I create a essentially what you're going to do is for the body, for the namespace ID, we use NoSQL 1. You're going to use the token, and then you're going to specify the name as collection 1. And if you get HTTP 201, which is typically how Swagger works, it gives you all the different HTTP codes. If you get a 400 or something, you'll get an unauthorized and so on. It'll tell you, it'll give you information on what's going on. Okay, so let me go back to my Swagger ID, to my Swagger UI. Okay, and find was it post collections? Yes, let's try that anyway. Create a new empty collection, right? So let's try it out. Okay, again, post the token. All right, namespace ID is NoSQL 1, right? Did I get it right? All right. and then a collection one, right? So let's go back to again the instructions. The name is collection one, very straightforward. I again cut and paste that, okay, and go back to my Swagger UI, and instead of this, I'm going to put a name collection one. So I'm creating a collection one in the key space NoSQL one using this particular token. And if everything works fine, I should get a 201. Okay. So you can see here, I got a 409 because I created something that already exists, right? So what I'm going to do is I'm going to create a collection called rags instead, right? And let's see what happens here. Okay, so it's pretty useful. You can try all this, and hopefully now you should get a 201 created. Okay, so it created the token, and you're good to go. Okay. Did it create? Yeah, so 201, the response headers are there, and you're good to go. Okay, and then you can go query the collection. Let me show you what all you can do with this. You can post, you can delete a collection ID. So what I can do is, I can go here and just give you an example of delete, right? Because I can, again, I have to go back, grab the token, right? Remember the token is very useful. So keep that handy. Go back here, put the token, and hit a try it out. Hit the token. Namespace ID is a NoSQL one, right? And let's see if this works. Rags, right? And let's execute that. Okay, so all that you're going to do is, you're going to pretty much do, exactly this. You're going to follow the instructions that are outlined in the GitHub page, and basically what it does is it lets you create a new collection, it lets you create a new document, okay, and then you can find all the documents of a collection within a particular collection, and then retrieve a document from its ID, search the document from the where class, and so on and so forth. Okay, so a whole lot of things that you can try out. My suggestion is let's move on to the next section. And then you can try it at your own pace. Okay, that seemed like a idea.
Yes, I support this idea because you can follow the instructions quite precisely to do the same thing that Rex did.
Yeah, you already see some thumbs up of people already have tried this out. So with that, Artem, back to you. I think you're good to go now.
Yeah. Okay, so the next one is key value databases. Key value database is the simplest one because they essentially use key value pairs. Key is unique, and usually the value can be in the simplest form. It's just a blob with some kind of data that is structured, semi-structured there, but the database doesn't look inside of the blob. However, nowadays we have key value databases that actually even support indexes and full text search. So they have sets, maps, they can store JSON documents. Again, there is this blurring between different data models. But here, yeah, we have this illustration here where we have the key that based on the key, you can retrieve some value from this database. The queries are quite simple based on key. Again, as I mentioned, there are all kinds of indexes nowadays that allows you to look inside and query based on what's internal structure of this value. Okay, examples here from React. This is how you can, so the users here, we had collections for document databases here with some databases call these buckets. So there is a users bucket, and we can retrieve based on the key with value Alice. We can retrieve based on the key Alice. We can retrieve value blob for that particular pair. Okay. But also, if you think about key value pairs, it's basically like a table with two columns where you have primary key or partition key, and you have the column for values. And this is exactly what we can do in Cassandra and AstroDB. We simply create a table with users with key and value columns, and we can retrieve that value based on the key. So this looks like SQL again. And this is, in particular, in this example, this is Cassandra Query Language or CQL. So these databases are best for simple primary key lookups. Even so, they may support all kinds of indexes. Still, the whole reason you want key value database is to retrieve very efficiently based on key. Otherwise, if you need to query inside of the structure, then maybe you just go with tabular database or document database that is designed specifically for that. So some use cases, caching, user session management, and serving content by key in general. So for our running example, this is only one way how you can represent our data set. I chose this way just so that you can see how to encode that thing, because the simplest way I could have done is just key would be user ID and value will be all the information about user and user accounts, just like similar to what we had in JSON. But here I broke down, I basically, each attribute is a separate key. You can see that we have entity of type user with this ID, with attribute name and value Alice. And we have another user, essentially an entity of type user, the same ID, but email is a different attribute, and it's a different key value pair. Okay, so it should be quite clear how to use it. Here we have the set of accounts for Alice attribute accounts. We have the set, so it should be quite clear how to represent the same data set using key value data model, and should suggest to you that if you're gonna use key value data model, then you probably will be retrieving those individual values very quickly. So this is like the user management, session management, and something like that. So you're just interested in one parameter. You are not interested in a bunch of values for that user. Otherwise, he would probably use a different type.
So Artem, my oversimplified view of this, again coming from like a programming world, is that a key value database is like a distributed hash table, if you will, right? So essentially, that's exactly what we do. We hash the key and go to a partition and retrieve it. But now, of course, there are a bunch of details that you have to worry about, like how do you persist the data, what happens if that particular node is down, do you have secondaries and all that. And that's exactly what a key value database buys you. You don't need to worry about any of those, but in your head, you think of it as a distributed cache or a distributed hash table, and the system will take care of retrieving the data for you automatically from whichever partition. And like Artem was saying, repeatedly, it is like a constant time for retrieval, because it's really going to the partition, hitting the key, retrieving the value. That's it, period, right? And it's great for those kind of use cases. So, all right. Do we have? Yeah, go ahead.
That's a good point. Yeah, that's a good point. I don't know if we want to do this exercise just for the sake of time. How about we skip it?
My suggestion is let me walk through that. Walk through meaning I will not do it, but I'll kind of walk through the instructions. Okay, and then what we can do is we can jump to the next section. Is that reasonable? Yeah. All right.
That's good.
So let me go back here. Okay, and key value databases, again, very simple to understand, very easy to use. But this, using this GraphQL schema and GraphQL is a little bit hard to use. Not extremely hard, but at the same time, it takes a little bit of getting used to. The first thing you're going to do is, you're going to go to GraphQL API, and then basically connect. And all of the instructions are in there. So you're going to do that. You're going to connect to the GraphQL playground, which kind of looks something like this, right? And then you're going to have these two tabs, the GraphQL schema and the GraphQL. My suggestion is, take this URL, right? Because you're going to be using this, when you're trying out the instructions, and keep it handy because you may want to get back to it. This uses the database ID, which region it is and all that. But I don't need to worry about this. Just keep it handy because you may want to get back to it at some point. But this kind of walks through the whole thing, right? GraphQL, and then what to do is we use what are called as mutations, and this is the way in which you can do a whole lot of stuff with GraphQL. And essentially what we are doing here is we are creating a table called KV. Okay, and the key space name is NoSQL 1, which is really what we used before. And then we have a table name called key value. And essentially here you have a partition key called name, type, basic, text. Very simple, right? You have a text, a key, and a value. That's all it is. And what, this kind of, initially you create the schema, and then you press the play, and then what you're going to do is you're going to go back to the GraphQL and then start inserting the values. And here's where, your URL should end with something like /API/GraphQL/NoSQL1. Otherwise, sometimes what happens is, and let me show this to you. If you hit the GraphQL, you'll see an error like this: server cannot be reached. And the reason behind that is because I haven't pasted the token yet. So to be able to paste the token, you have to go and populate this particular token. But sometimes, if your browser is not the full size that you can see here, right? Then you may get into some kind of issues. So that is why I recommend using this, copying this, URL, because it might come in handy later. Okay. So you're going to create the table. Then what you're going to do is you're going to add, values to it. And then this is the nice part, right? You're going to go back to your SQL console. Okay, and let me show that at least in action, right? Because I've already created this, right? So I'm going to go back, connect to my SQL console, okay? And I'm going to use the same key space, NoSQL 1, right? And I'm going to cut and paste what was in there. Again, not a good idea to do select star, but, because what you're doing now is going to each and every partition, so depending on how big it is. I mean, of course, I don't have too much here. So, for the purposes of illustration, this is probably okay. But again, what these instructions go at pretty, length about, how to do this. And you can kind of improvise this a little bit yourself and kind of change this around. But essentially what you're going to do is you're going to use these two, which is, let me go back here, the GraphQL schema to create the table and the GraphQL to actually insert the entries, okay? And let me, just so that I'm not pulling from thin air, I'm gonna copy this token, okay, and go back. And if you populate me, hopefully actually, let me go back to GraphQL schema because you'll see the same thing there as well. Okay, and I'm gonna put the token and hopefully it should validate, okay? At least, it requires authentication, but you kind of get the idea, okay? You'll have to put this token first before you can get started. Otherwise, your authentication is not fair, okay? I know it was a little bit fast here, but again, in principle, it's the same. The reason why we chose, the GraphQL playground is because it does a whole lot more than this. But again, to kind of give you a flavor, I know that Artem touched upon these different, kinds of databases. But from a programmatic perspective, there are different ways of accessing this as well, and that's kind of what we're showing here. So once you start putting them in a matrix, it becomes a little complicated. But the idea is that take them one by one. I think most of you are very familiar with SQL now, SQL console. Get familiar with GraphQL, and then go on and use the Swagger, or whichever suits your fancy. You can do that. I know the last thing that we want to talk about is graph databases, and I know that Artem prepared a demo. I'm not sure if you have the time for that, but I will hand control back to Artem, and you're good to go.
Yep.
Hold on one second.
Yeah. So graph databases is the last one, and graph databases use graph as a data model. Graph has vertices or nodes. It has edges that connect those vertices, or can be called links or relationships. And there are also properties that describe edges and vertices, basically like attributes, right? So there are also different types of graphs. So some databases use property graphs. Some other databases use RDF graphs. I'm not going to talk about differences at this point, but here we have examples of DataStax graph, Neo4j, Allegro graph. These are property graph databases, and Allegro graph uses RDF as a graph data model. The query languages, again, can be quite diverse. There is a Gremlin that we're going to use, which is more like a functional language, Cypher, and GSQL and Sparkle, 3 different languages, and you get GSQL, Graph SQL, so it should be similar to SQL. And these three, the last three, they are more of a declarative languages where you define a graph pattern that you want to match against your graph structure. But Gremlin is more like a traversal language where you want to define how you're going to traverse that graph structure. So use cases. So this example of Gremlin here, let me just walk through. So starting with our graph traversal source, but essentially think about it as graph. We get all vertices that have label user and name Alice, and then we will repeat the following. We will traverse in both directions, so edges have direction, and we will make sure that it's a simple pass. There are no cycles. There will be time limit, how much time we want to spend, 800 milliseconds doing that. And we will keep traversing until we see the another vertex with label user, value, and property name with value above, and we will get the path. So essentially what we're doing here is trying to find the shortest path between Alice and Bob vertices in our graph, right? So use cases here is exploring connections, links, relationships. They all have to be related to that. So it's a little bit more than just simple, okay, retrieve by key. No, what's the connection between Alice and Bob? And you don't know how many hops you need to take. Is it 2 edges you need to traverse, or is it 5 edges you need to traverse? So customer 360, personalization, fraud detection, recommendation, internet and so on. But you can see from these use cases, they frequently involve some analytical aspects. A little bit more than just collecting data and quickly retrieving it, but also kind of a little bit analysis starts to get used in those particular applications. So the data model is super flexible, and you can use it to capture any other data model that we discuss, including relational, but there will be some disadvantages too. So here in our running example, we have user with particular ID. It has 2 properties, name, Alice, email, and there is an edge with label has. User has this account of type and balance. And the user has another account with different ID, and there is a type savings and balance property 1500. Similar for Bob. So it's quite easy to use to model using that, but still there will be data modeling involved. And for the exercise, for the hands-on, I'm gonna just show you a quick demo using these so-called path traversal. So using Gremlin and Gremlin quick and using graph traversals. The system that we're using behind the scenes is DataStax graph, and this is web client called DataStax Studio that allows me to interact with the database. So I already pre-created the database for you, so we don't spend much time. It has schema. The graph has schema, so it has vertices with labels, movie, user, genre, and person. And there are edges with labels rated, nose, and so on and so on. So we're not going to drop the schema, but this is the code that creates the schema. You can see we created vertex labels, edge labels, specified how to partition, specified the properties, just to give you an idea what it takes to work with graph database. And we also created a bunch of indexes as well, vertex indexes and edge indexes. And we loaded the data. And there are multiple ways how you can load the data. But now let's query the data. Let's execute something simple. So we will find person with name Denzel Washington, and we will traverse actor edge in any direction. So it can be incoming or outgoing. So this step both, and we will get the pass. Let's see how it works.
So is it safe to say that a graph database is like ultimate in relations? I'm just pulling up on that.
It is.
Yes, I mean if you
just yes. It is safe. It's the ultimate database for that.
It just looks so cool, right? You know, because it's really expressing all the different relations, different degrees, and so on. So.
Yeah. So what we did, we went from this vertex Denzel Washington, and we traversed edges in both directions. These are actor edges. So we went to the movies, and from there we went traversed actor edges again. So we found all the other actors who participated in the same movies with Denzel Washington. So this is one example. Let me just select another example. So here is a simple example where we want to find the pass between Denzel Washington and Arnold Schwarzenegger. And we traverse actor edges twice, but we will not find anything. There will be no results. The pass does not exist. So what we do here is this is a simple example that you've seen in the slides, but essentially we will do the repeat construct here, repeat step. So it's going to be a loop. We're going to be running it, and to find that shortest pass between two actors. And you can see it exists, and there are a couple of movies involved, but the pass between the two actors exists. Okay, and so let me show another maybe subgraph traversal example. Okay, we're using the same graph, but we're going to traverse users here. So essentially, I'm going to retrieve the neighborhood of one user. And it's a random user. And that first one was only knew one other user. So it's basically a neighborhood of one user. And it's all actually interactive. So you can expand neighborhoods if you want and see larger neighborhoods. Okay. It may take a little bit of time. And so more interesting example, maybe finding friends of friends. So and again, this is a random user selected. And we find, so the graph is different each time. Okay, and so on. So hopefully this helps to just get an idea what is possible with graph. So it's like doing the little bit of a social network type of processing in this example.
Perfect. Yeah, I think that's great. Do you want to mention that our instructions don't really I mean, we have something more involved with the Docker Compose if you want to try it yourself. You know, do you want to add a little bit? Yeah.
That's right. That's right. Yeah. So the demo I showed you is just running in the cloud, and I'm just accessing that instance in the cloud. But you can also, if you follow the instructions, you can use Docker to basically have the image with DataStax graph installed, and you can run it locally on your machine and do the demo. And this one particular is optional for you for your homework. If you don't have time to do it, that's fine. But at least you saw the whole idea was here is to show you the capabilities of different databases and get the feel, a look and feel of how they actually work. Okay, so now which database are you going to choose? Which for your application for a particular use case? Okay, so it would be a good idea to consider. So I think am I Rex? Am I still sharing the screen?
Let me do that for you.
It's okay, but if you go to slide 46,
no, you go ahead.
Finish.
Yeah. I will make sure my monitor is turned off, and you can. Yeah. Sorry, go ahead. Keep talking. Yeah.
Okay, so which one will you choose? The is it tabular document, or maybe key value or graph? So consider using a multimodal database, because different use cases will require different data model. So if you're gonna do session management, user session management for a web application, then maybe key value is the best. If you're gonna do traversals in the graph, you're gonna look for paths between two people, connections between two people, then graph will be the best. Most of the time, tabular or document will be a choice, and they are kind of in the middle on this diagram, so which compares scalability and value in relationships. So you can see graph databases, they can kind of have they are more complex. Their queries are more complex, so their scalability will be less than, let's say, tabular or JSON. And definitely the simplest one is key value, so it has higher scalability. And the fact is, most of the time you will use, not most of the time, but if you not only looking at one application, but you look at the platform that involves multiple applications, like e-commerce may have multiple applications, fraud detection will have multiple applications that are doing different things. So sometimes you will use tabular and put key value in front of it for caching purposes. Tabular will handle more complex relationship, but for speed, you may only retrieve certain things using key value. And certainly I've seen many use cases where you use graph for more complex things, but then the graph contains references that lead you to, for example, tabular database. So for example, you may have sensor network represented as a graph in a graph database, but the data that each sensor collects will be stored in tabular database. So it's not one model that's gonna fit all use cases, definitely not. And besides the data model itself, you need to consider performance. You need to consider use case, scalability, availability that your application need, global distribution, multi-cloud, will it run multiple clouds on, or you find just one. Whether you have database as a service offering or not, because that will simplify your operations significantly. And with that said, we are ready to talk about what is next. And Rex, you
perfect. I know
over.
it's a very critical, slide where you pick the database that you want. But please join us in Discord where you can get more information. We really don't have the time today, and I want to be cognizant of time. And I know that many of you join us because you want to do the mentee. Mentee is pretty cool, so we're gonna jump straight into the quiz. As a special bonus today, we have top 5. Okay, so usually we only give out swag to top 3, but today we're going to give out swag to top 5. So stay here because here's your chance to win swag, and 2 more chances to win swag, because like I said, usually it's 3, but it's 5 this time. Okay, so with that said, let me jump to mentee. And again, if you don't have the code, ask Nightbot. Nightbot is our basically our self-help system that will help you, give you mentee code, GitHub, and so on and so forth. But if you want the code, it's here. Okay, let me make sure I'm getting it right. All right. Go to maintain, use the code. Okay, give me a second. Mentee is misbehaving for me right now. So let me start presenting and quiz time. Okay, let me see how many people are joining. We need to have at least I have about, all right, leave the page, go away. Yeah, okay, so here we are. And let me put it on full screen. All right, and again, you can see 48153410. I'll make sure I'll turn on the music. We'll have some music here to play. Let me know if it's too loud and I'll turn it down. Okay, if somebody can give me a thumbs up that the quiz music is perfect, then it'll be great. Okay, with that said, let's jump to the questions, right? We don't have too much time, right? Okay. Come on. Okay, I don't think it matters. Close the other window, that's all right. Okay, my bad. My apologies for this. Let me see if I can fix this. Let me try again. Let me see if we can present this. You may have seen some of these already, okay, but let's keep going. Mentee is a little finicky sometimes. Okay, answer fast, but most importantly, answer accurately. Which database should you use for high growth applications? Aaron, you want to comment on this? Relational database, hierarchical database, NoSQL database, or object database? Perfect. I think we have a few who said no, not a NoSQL, okay, but I don't know if you guys are so passionate about those other databases, but I think NoSQL is really great for high growth applications. Like I said, Facebook, LinkedIn, a lot of those born in the cloud companies, right, are using NoSQL database in some form or another. Any comments you want to add, Artem?
Yeah, there are some relational database diehards.
Yes. So let's see how the leaderboard is working, and it's not letting me do this. I'm not quite sure what's going on here.
Yeah, and by high growth applications, we mean exactly the scalability and performance for very large data sets and large amounts of concurrent transactions. So it's a high throughput types of applications, like you find in IoT or even in e-commerce when there is the seller is serving multiple millions of customers.
So let's see how the leaderboard is facing, looking. We have Gokul as the fastest, and on top of the leaderboard, Yashwendra is next, and Shannon. Skids could come through, because the top 5 is going to get swag today. Okay, that said, let's move.
Very close competition.
It is close, as always.
Yeah.
Question 2 of 8. Answer fast and answer right. All right. Additional benefit of NoSQL database. What is it? Look at your phone, not on the chat. Is it faster joins? Is it no need to design a database schema? It's simpler to operate? Better performance and scalability. So you want to comment on this, Artem, especially since a lot of people said no need to design a database schema. Is that why would many people think that way?
Yeah, I have a bit of a delay. So, yeah, no need to design database schema is probably they referring to document databases. Indeed, it can be one of the advantages, but just understand that you still need to think about structure of your documents. It's not just, you cannot just randomly put things there. You need to think about what will be nested where, what types of arrays you will use, how you're gonna access data. Otherwise, it's always you design you model your data based on the access patterns for any type of NoSQL database. So you will still have to think about data modeling and schema inside of those documents.
Moving on. Sorry.
But indeed, there is.
Let's see how the leaderboard is shaping up.
Let's move on.
Looks like there may be some change. Maybe. Oh, Shannon jumps to second. Gokul is still fastest, and you know is on top of the leaderboard. But anybody's game at this point. Okay, moving on. Next question. We have 5 more, I think, or 6 more, right? All right. Answer fast, but more importantly, answer correctly. What is AstroDB? It's a local in-memory version of Cassandra. It's Cassandra as a service on the cloud. It's an album by Radiohead. I distinctly remember. Maybe it is. And is it a development tool? Is it maybe an IDE? Wow. I think we did our job, right? We got most people, some people thought it's a development tool. It is a development tool in a way, right? You know, but really it's more importantly, it's Cassandra as a service on the cloud. Let's see how the leaderboard is shaping up. You know, we got to move a little faster here, right?
Yeah. Database as a service.
Yes, database as a service, Cassandra as a service, database in the cloud, you know, any of those. Yes, man. Whoa, was fastest. And Shakib, you can still get to the top 3. Gokul still maintains the lead. We have Karthik, Reddy, Tumuru, who is below, but could jump. Sabina, you know, you could get to the top 2. Which anybody's game right now, right? There is He-Man and Yes-Man. Wow, interesting. Okay. All right, moving on. Question 4 of 8. We are at the halfway mark. Which NoSQL database organizes data into tables with rows and columns? Is it relational database? Is it a tabular database? Is it a document database? Key value? Graph? Or our good old friend, Microsoft Excel?
I wouldn't even talk about Excel.
I know, yeah. So thankfully nobody got Microsoft Excel. But I think most people got this right.
Yeah,
so,
Excel is a desktop. It's a desktop.
Yeah, anything you want to add color here, Artem? Yeah, all right.
Oh,
moving on,
good.
leaderboard. Let's look at leaderboard. Let's see how it's shaping up. Ooh, looks like Gokul might still be in lead. Very close. Yes, man is making the move. Bharadwaj. Fantastic. He was the fastest. Then we have anybody else. You know, Venkadeshamala, you know, almost there. Ashok Kumar. Anybody's game right now. We still have 3 more left, I think. 3 or 4 more left. 4 more left. All right, let's get through this. Answer fast, but most importantly, answer correctly. Which NoSQL database is better suited for finding a shortest path between entities in a network? Is it a traversal database? Could it be? Could it be a document database? Graph, key value, or tabular? Seems like it could be any of those, no? Graph database, and most people got this right. Key value is good for key value as it says, right? But if you want to find a shortest path between entities and follow some relationships and so on, Artem talked about how you can find the nearest neighbor and so on, right? So I think the graph database is the best. Anything to add, Artem?
That's right. And I can say that some key value databases nowadays have graph support as well. So
okay, fantastic. So those are the people, the 23 people.
They maybe use those.
Yeah, maybe they've used that, but really the most appropriate one is the graph database, right?
Yeah, that's right. Yes.
Yeah. All right, let's see how the leaderboard is shaping up. Looks like Lalit is making a move or somebody. I don't know. We'll see. Gokul still retains the lead. Wow. Shannon was the fastest. Man, we have all over the place. This is so cool. But again, anybody's game. CG, Suresh, Vijay, Jade, Salman, any of you, right? All right, moving on. Question 6 of 8. We have 3 more, right? 6, 7, and 8. So let's start the countdown. Answer fast, but most importantly, answer correctly. A key value database, nice segue, is supports complex relations and joins, is perfect for simple key-based retrieval, is perfect for doing some very complex analytics, always stores valuable cryptographic keys. Interesting. All right, that's very cool. We got is perfect for simple key-based data retrieval. As it says, a key value, you have a value, you have a key, and remember I talked about like a hash table or a hash, and that's exactly what a key value. A key value database is. You give it the key, you get the value back, and you're good to go. Okay. All right, let's not dwell too much on that. Let's go to the leaderboard. Will anybody be able to replace Gokul as the leader? Maybe not. Gokul was the fastest, so there's no way you can replace. But there is still 2 more questions to go. Yes man could become the top man. So let's see how that goes. Moving on. 2 more questions, 7 and 8. All right. Answer fast, but most importantly, answer correctly. Right? What format does AstroDB use to store and retrieve documents? Ooh, this might be a tough one. This might be a tricky one. Is it XML? Is it JSON? Is it HTML? Is it binary? Or is it tabular? JSON. A lot of people got it, right? Tabular might be a little bit misleading there. Ultimately, everything is stored as binary, right? I'm going back to my computer roots, right? But we store it as JSON. Again, Artem, maybe you should take over. Anything to add?
Yeah, well, for tabular, actually, you showed the example of how to store it in just tabular in a table, right? Yeah. So that's not a incorrect answer.
Yeah, also. Yeah. So maybe we should extend this and add both tabular and JSON. Okay.
Yeah, you did the insert for it's basically JSON data type for a column.
Yeah. All right. Let's see how the leaderboard is, and for all the marbles, we have 1 more. Oh, what happened here? Looks like the leaderboard got completely changed here. Wow. There are 2 fastest. I've never seen that before. At least not in the ones that I have conducted. Shannon and Avnesh. So there is 1 final one. It could be anybody at this point. Gokul, you could still come back and jump in. Rajendra, Jay, any of you can still make it. And remember, we are looking at top 5. So also this, although the screen might say top 3, it's going to be top 5. Okay. And we'll tell you what to do if you're the leader. The last question. Ready? Go! Which property of a distributed database is not mentioned in the CAP theorem? Ooh, this is interesting. CAP. Consistency, availability, is it partitioning or partition tolerance? I have a feeling it's got to be the last 2. You really managed to trick them, right? it's like partition tolerance and consistency and availability is what is part of the CAP theorem. Partitioning is not part of the CAP theorem. Although, when you talk about network kind of breaking up, it could kind of partition itself, right? But we are really more talking about the partition tolerance than the partitioning part itself, right? So the CAP theorem really talks about the partition tolerance and not the partitioning in the traditional sense.
Partition tolerance, network failure, right? Dividing network into subnetworks. Partitioning, here we refer to data partitioning, dividing table into multiple partitions, so something like that.
Very, very tricky. You got almost the same number of responses for partitioning and partition tolerance. Tricky you. All right. So this is the final leaderboard.
But there may be surprises in the leaderboard.
Surprises for sure. Salman, congratulations! You are the winner.
Good job.
So what I'll do is I'll let you guys take a screenshot of this, especially the first 5. That is Salman, Shannon, Rajendra. Is it Vijay and Yes Man? Take a screenshot, and we will tell you in a moment what to do with it. Okay. I'll give you a couple of minutes, or maybe a couple of seconds. But I think it was a rather fun mentee. But in the meantime, if you can send us a quick survey, what do you like most? What should we improve? And we are pretty open here. You should see the responses here. Let me go back to the presentation, and we should wrap it up really quickly. Okay. All right. Let me go back to the presentation. We did the mentee, and now I'm gonna wrap it up. Okay, so what do you do if you're the leaderboard? It says congratulations to the first, second, and third, but we got some special permission today to give out more swag. So the top 5 are gonna get swag. All that you're gonna do is you send an email, take the screenshot, and send it to Gary Harvey at datastax.com, and you're good to go. Okay, so again, 1 through 5. Okay. Please take a moment to review the homework. If you hit exclamation homework, you should be able to see that. Intro to NoSQL homework, basically run through the exercises, and there are some optional parts as well. Okay. You run a catacoda scenario, submit a form with your results, and you're going to get a badge back. Okay. Nice looking badge, cool looking badge, which is the introduction to NoSQL. We also sponsored your education and certification. If you want to scan this, I believe you can get a certification voucher that you can use. Okay, it's valid for 3 months, valid for 2 attempts, and you can use it as and when you please. Okay, there are lots of other certifications as well. Welcome to kind of check this out. If you go to datastax.com/dev/certifications, you should be able to see all that. And like I said, plenty of resources. For you to use. I myself do a lot on the Kubernetes side and Cassandra. So if you're interested in that side, you can do that because Astra uses Kubernetes underneath, but you are not able to see that, and you can't control that as much as you want. You can do that with Cassandra. There is administrator certifications, there are developer certifications, all kinds of cool things. But more importantly, we have a build-a-thon that's going on right now. And there are opportunities not just to win. I'm not going to say that the t-shirt is not cool. T-shirt is cool. The swag is cool. But you can get money, actually. I believe there is something like a $45K US dollars, $45,000 US dollars. 41,000. Okay. Correct me.
41,000.
Yeah, and
the largest prize you can get is $5,000. For
exactly,
finalists.
and it actually, we're calling it the side hustles. We realize that all of you are professionals, busy with your everyday life, but take a moment to kind of try something with Astra. Maybe build an app for us and put it in there, okay? And you can also win some money as in the process, okay? All that the hackathon requires is you have to use AstroDB as your backend, okay? Pretty straightforward. If you have some more detailed questions, just join us at Discord. Discord is the place where you can get pretty much any questions you want answered. All of us are hanging out there. We really strive to answer your questions as soon as possible. But again, you can help us by actually answering those questions as well, because you may have a little bit more information. Do subscribe to our channels. Whatever, there are a bunch of channels that you can subscribe to. So take a moment to review that. And with that, thank you very much. Thanks everybody for coming. And you want to wave, Artem? With that.
Yes, thank you very much. It was a pleasure. Thank you for your questions, for participation, and we hope to see you again
Thank you
in
very
the next
much.
workshop.
And as always, don't forget to click that subscribe button and ring that bell to get notifications for all of our future upcoming workshops.
Imagine a being gifted with powers from the goddess of Cassandra, who grew those powers until she could multiply at will, move with limitless speed, and unmask hidden knowledge. With those powers, she was able to fully understand the connectedness of the world. What she saw was a world in need of understanding. From that day forward, she sought to bestow her powers on all who came into contact with her, empowering them to achieve wondrous feats.
Yeah. It's very intense.